All right, gang, I have mentioned previously in instructional videos in this lesson that sometimes confidence intervals and hypothesis testing results do not agree. And I think it's only fair that I take about 5 minutes and illustrate uh, a situation where that happens and try to explain it. Again, I do this in hesitation because I'm afraid that it's going to complicate things or confuse you. That's not the goal here. It's just to let you know this happens. You can put it on your radar and react however you want to react, I guess. But it can be confusing, but it's just one of the caveats of uh, when CIs and HTs don't agree, okay? And it only happens when we get into one-tailed test. So greater than or less than, we have the potential for these things not to agree. As long as we conduct a two-tailed test, not equal to in the alternative hypothesis, keeping our alpha stable and using the corresponding confidence interval, which in this case would be 95%, we don't get into that. But let's see the way it works. You can still have the information from the previous video. So if I was going to work a confidence interval for this problem, I would go to tstat and with summary, type in the information. I should have already had this done. I think you're more likely to play along with me if I don't. Our sample size is 50. So if I want a confidence interval, 95%, I don't need the z critical. Let's just get the confidence interval. So this is going to run from 19.93 to 21.47. Now notice that 20, which is the hypothesized value, is contained in our interval, so it's plausible to believe, since the interval we're using to estimate 20, estimate mu, I should say, when mu is equal to 20, if 20 is in our interval, it's, sorry, I'm not bright enough apparently to speak and write. It's plausible that we would fail to reject the null and conclude that there's no reason to reject this. The mean appears to be 20. Now, if we do the same calculations with the same data, right, but we run a test of hypothesis for a value of 20, but we run a one-tailed test greater than 20, and let's see what we get. Well, we get a p-value of 0.0364. Which is less than our stated alpha value of 0.05. So that leads us to reject the null hypothesis. So again, conflicting results with the confidence interval and a test of hypothesis. Now again, how can you make sure that this never happens? Well, just always test not equal to. Yeah, let me show you how that plays out. If we test not equal to, and let's say that we end up, this is super annoying, that we end up rejecting. So if we reject the null, what does it tell us? We don't believe that statement. We believe that the mean is not equal to 20. Well, I don't know about you, but just a statement the mean is not equal to 20 doesn't give me any indication of what 20 is, or I'm sorry, what the mean is. And not equal to 20, was it 25? Is it 12? Is it negative? Is it positive? You know, a lot of unanswered questions. Well, what I would do next is I would follow up with a 95% confidence interval, again, assuming this is 0.05, the level of significance is 0.05. So if I get a 95% confidence interval of 18.2 to 19.4, since this entire interval is below 20, I conclude the mu is less than 20. If I get a 95% confidence interval from 21.2 up to 23.7, the entire interval is above 20. So I would conclude, therefore, that the mean is above 20. So I can actually, in a tricky way, perform a directional test using a two-tail approach. And I'll be very transparent in my research. In all the research that I've served on to this date, 15 doctoral advisory committees. In other words, I've served on the committees that people have worked on their doctorates. And I've been the master's thesis advisor for, I think at the end of this year, it's going to be 119. So I've had a lot of publications that have been done under me. I always take this approach, and my students always take this approach. Test not equal to, make your decision. If you reject, calculate your confidence interval to get an indication of the estimate of the value of mu that we rejected up here. Now, if you fail to reject, there's not much need to follow up with a confidence interval. So anyway, my intention here is not to confuse things. I just wanted to give you because I've mentioned this before, and in all fairness, it comes up in your homework assignments. All right, that's all I got.